Hello friends, a very good morning or a very good evening to you. And today we're going to learn about crystalline solids and amorphous solids, the differences. And I'm telling you, this will be a very good explanation of all the points that we have read. You will also understand as to why do we, why is the characteristics like this or why is it not like this. So first of all, this will be helpful for if you're a student of class 12 preparing for JEE, IIT, JAM, or even if you're an M.Sc student and you want to know about solid state. This will be very helpful. So we'll learn about crystalline and amorphous solids. First of all, I'd like to show some pictures of crystalline and amorphous before getting into it. So this is how crystalline looks, okay, and this is how amorphous looks. So just have this picture in mind as we're going to talk about the points. So we're going to relate all the points I'm going to talk about with this picture, okay. And first of all, we start off the first property, that is arrangement of units. So you can take a screenshot or you can take the notes as you think is fit for you, okay. So arrangement of units or the structural units, it might be atoms or whatever we are talking about over here. Atoms, molecules. So how are they arranged in crystalline or amorphous? So in crystalline there's a regular arrangement of atoms, okay, but in amorphous there's a not regular arrangement of atoms. As to what does this mean? This means, suppose as in this picture you see that the atoms are arranged in a regular manner. There's some pattern to it. There's some periodicity to it. But for amorphous there is no regular pattern, no such periodicity in it. Okay, so this is what it means. And if there's a periodicity, we can say it's a long range order. Okay, so this periodicity remains for a long range. Okay, because there's a pattern to it, but there is no pattern as such. So therefore we call it short range order because the range is very short. Okay, you understand that point. And now we'll talk of the geometry. So geometry, as you can see, for crystalline it's a very definite geometry, okay, but for non-crystalline the geometry is not at all definite, okay, as you can see in the picture. Okay, so we can actually suppose I take this black pen, we can actually say maybe this crystalline is made up of hexagons like this, okay, and or maybe there's some hexagons repeating in it, there's some squares over here like repeating in it, okay. But for amorphous you can see there's no pattern to it, there's no regularity to it, we cannot say it's in any way definite, okay. But in crystalline we can see there's a definite structure to it, okay. So this is what it means. Now let us talk about the melting point. It says that there's a very sharp melting point for crystalline, and for amorphous there's not a sharp. So what does a sharp and not sharp mean? Sharp basically means there's a point to it. Suppose this melting happens at, you can say, around 80 degrees Celsius, okay, around 80 degrees Celsius the melting happens. So there's a definite amount to it. But for not sharp it means, oh, it can happen around 60 degrees Celsius, it can also happen around 90 degrees Celsius. And this is very obvious. Why is it very obvious? Because see, there's a definite structural unit. So whenever you you're heating it, it will be melting at the same temperature or at least like 1 or 2 degrees different. But in amorphous you see there is no definite structure to it. So sometimes you might heat one part and it melts at 60 degrees Celsius, you heat another part and it melts at a different temperature, right? So now similarly we'll talk about heat of fusion. So first of all, what does heat of fusion mean? So this just means, in thermodynamics we'll study the del H, the change in enthalpy associated with fusion. So for the ones who don't know what del H is, I'll just simply say it's called actually enthalpy, and but you can simply as of the moment can think of the heat change, okay, the heat change associated when fusion happens. When fusion is happening, fusion is what? When your solid is melting to a liquid, when fusion is happening, and the heat change associated to it, okay. So that is what it means. And what do we see over here? That it has a characteristic heat of fusion. What does characteristic mean? And in amorphous doesn't have a characteristic, similar to definite and non-definite, it or sharp or not sharp. Characteristic means that the heat of fusion, suppose it always is found that for this particular, suppose we are talking about NaCl. NaCl is a crystalline structure, so I'm just saying for up, so we always find the heat of fusion to be around 80 kilo, so 8 kilojoules, okay, always find around 8 kilojoules. But for suppose glass is amorphous, so it's not characteristic. It means that sometimes heat of fusion we may find at 2 kilojoules, sometimes we may find at 0.1 kilojoule as well. Okay, so it differs. There's no characteristic point to it, there's no definite point or sharp point to it. But for crystalline we can see there's a definite and a characteristic point. Characteristic basically means that through the heat of fusion you can characterize that the material is what kind of material. So now I'll talk about compressibility. Compressibility, the Our crystalline materials, they are incompressible. Okay, you cannot compress them really, and that is because also because of nature, because they are true solids. You can see the nature because they are true solids. So as in solids, as you can see also, they are very tightly packed, and as in solids are very tightly packed. That's why they are incompressible. But for the amorphous ones, you can see they're like supercooled liquids or pseudo solids. Okay, so see, you can see they're not tightly packed. There are vacancies over here, here. Okay, and that is the reason that they're compressible, because there's space in between, right? So that is the difference between nature and compressibility. And some examples of crystalline is that is of diamond and NaCl, and of amorphous you can see examples of glass and wax. You can just think and imagine how these points are related, how diamond and NaCl, if you just think diamond, okay, it has a regular pattern, it is very sharp, it's characteristic, so if you understand the points, if you can think about it, then you can easily say what the points are. So one more point which I did not cover is that crystalline surfaces are anisotropic and non-crystalline surfaces are isotropic. So what is this anisotropic and isotropic? Well, this is actually, I'll have to explain this, and so for that I'll show it in the next video. But just remember all these points, and I hope you could understand the things I could tell you. Okay, and I hope it was a good learning experience for all of you. Okay, bye bye.